In this video, we're going through a couple of examples for some of the formulas that were covered in Chapter 4. So the first one we're going to look at is that moving average. So we're assuming that our stock of sales merchandise is maintained based on the forecast demand. We're looking to use a simple moving average. What is the forecast for September? Okay, so when we look at, take a pen, our simple moving average is the actual sales for previous periods divided by the number of periods. So we have 3 periods here. So we would have 140 plus 180. Oh, please forgive my writing here. Plus 170. We would add those together and divide by 3. So if we calculate those out, our demand for September equals 163.3. Okay, so that's just the simple moving average. What is forecast for September? So using an exponential smoothing and assuming that the forecast for June had been 130, we're going to forecast sales for September with a smoothing constant alpha of 0.30. So I'm actually going to split the screen for this, so just 1 second. Okay, so looking again at this moving average, we're going to use exponential smoothing and assume that the forecast for June had been 130. So when we're looking at exponential smoothing, we have that the forecast, let's make that font larger so you can see it. Let's pop it up really big. So forecast equals the previous forecast plus our smoothing constant of alpha times actual sales minus forecast sales. Okay, so we have to look at each month. So we're looking for what is the July forecast. So we take the forecast for June. So the June forecast was 130 plus the alpha of 0.3 times our actual June sales of 140 minus our forecast of 130. So we get a July forecast of 133 units. Now we're going to calculate the August forecast. So we're looking for, we have 133 is our July forecast plus our exponential smoothing alpha. Our July sales were actually 180 minus our forecast of 133. That gives us an August forecast of 147.10. So then we're ready to do our September forecast. So we have 147.10 plus our alpha, and then we have our actual August sales of 170 minus the forecast of 147.10. So now our September forecast is 153.97 or 154 units. So we have the difference between our moving average with exponential smoothing, which gives us 140 units or 154 units, or the simple moving average, which gave us an estimate of 163.3 units. So trying to decide which one we go with, and we might decide that we go with something in the middle. Okay, The next example that we're going to look at looks at economic order quantity. Throw this up just a little bit. Okay. And so we're going to calculate the economic order quantity. So that is our quantity equals the square root of 2 times the annual demand times the order cost. So if you remember when we look at our information, so I'm going to draw here. So we have the square root 2 times the annual demand. So we have 500 units times the annual carrying cost, or the order cost of 100. What just happened? Not sure what just happened there. So divided by the carrying cost. So 20%. So 0.20 times the cost of a refrigerator. So if we type that information, so if I remove all of that, type up, so we have 2 times annual demand times order cost divided by the annual demand times the holding cost. Okay, so divided by, and then the square root of that total. So what we get is that the economic order quantity is 32 refrigerators. Okay, so 32 refrigerators. So then we have 500 as our annual demand. We want to order 32 each time we order. So 500 divided by 32 is 15.625. Okay. So our economic order quantity is 32 refrigerators. We want to do 15.625 orders a year, or 15 or 16. And so we would determine if we want that to be 15 orders or 16 orders. Okay. Then if we're looking at if the distributor wants a 97% service probability, what reorder point or R should we use? When should we place our order? So remember, that's a factor of our lead time and our demand. So if we go to the standard normal distribution table in our textbook, we get a z-score of 1.88 for that 95% or 7% standard deviation. Okay? So we put that into our formula where we look at what is our our daily demand. So we want daily demand. So we have annual demand of 500 refrigerators divided by 365. We take that times our lead time, which is 7 days, and then we add that to our standard deviation, 1.88, times that standard deviation of demand during lead time. And when we calculate that out, we get 28 refrigerators. Okay, so our reorder point is 28 refrigerators. Once we hit 32, when we hit 28 refrigerators in stock, then we place our next order for 32 refrigerators. Okay, so our next slide, we're looking at daily demand for a product. So we're going to erase all this. And we're going to look at the daily demand for a product is 100 units. We have a standard deviation of 25 units. We have a review period of 10 days and a lead time of 6 days. At the time of review, we have 50 units in stock. If we're looking for a 98% service probability, how many units should be ordered? So if we go to our standard deviation table at 98%, we have a z-score of 2.05. Okay, so then we take our lead time plus our review period. So 10 plus 6. Okay, we take that times the standard deviation squared. So we need to square that. And we get 100 units. Okay, or we get 100. Then we put that into our previous equation. So we have a daily demand of 100 plus our lead time and our review time, and then our standard deviation. Okay, and so our next order, minus 50, because we already have 50 units on stock. And so our next order should be 1,755 units. Okay, and those are some of the examples from chapter 4.